Good morning. My name is Sugata Sanyal, founder and CEO of ZINFI, a proud alumnus of the New Jersey Institute of Technology. I'm super excited to introduce Dr. Senjuti Basu Roy, a leading expert in AI, data management, and sustainability. Dr. Basu Roy holds the Panasonic Endowed Chair of Sustainability at NGIT and serves as the director of the Big Data Analytics Lab. Her research focuses on human-in-the-loop AI, the future of work, and responsible data management. Over the last 6 years, she has secured over $10 million in research funding. With more than 85 publications and over 4,000 citations, Dr. Basu Roy has earned many accolades, including the NSF Career Award and recognition by the National Academy of Engineers. Please join me in welcoming Dr. Senjuti Basu Roy to our podcast today.
Good morning, everybody, and good afternoon if you're joining from my side of the country. Thank you, Zinfi and Sugata, for inviting me to speak here. I'm super stoked. I'm Senjuti Basu Roy, an associate professor of computer science at the New Jersey Institute of Technology. My background lies in large scale data management, and these days I spend significant time in doing human in the loop AI research. My academic career started in this country as a young graduate student about 19 years ago, and ever since I have been embracing all the curveballs it has been throwing at me. But in all seriousness, I absolutely love what I do, and I do not know what else I'm good at. So thank you. So I'm going to talk about AI and the future of work. This topic begs a deeper insights more than ever now. To substantiate with some credible data and facts, let me start with this 2023 McKinsey report that many of you are aware of. According to this report, during the pandemic, the US labor market saw 8.6 million occupational shifts, 50% more than in the previous 3 year period. By 2030, it's been projected that activities that account for up to 30% of hours currently worked across the US economy could be automated, a trend accelerated by generative AI. It's been projected that an additional 12 million occupational transition may be needed by 2030. In fact, women are 1.5 times more likely to need to move into new occupation than men. And most importantly, the United States will need workforce development on a far larger scale, as well as more expansive hiring approaches than from employers than ever. So, really, the thousand-pound gorilla in the room is this overwhelming question: AI as a disruptive technology, is it a boon or a bane to future of work? During this podcast, I plan to lay out some facts, some point of view which are solely mine but derived based on evidences, and some vision. I want to discuss facts describing how AI based innovations shaping our workplaces. I also will lay out my point of view describing key challenges that will or have already started disrupting traditional workplace practices. I'll highlight my vision describing workplace skills we will need for tomorrow and how we can harness AI to enhance creativity, collaboration, and productivity, unlocking new possibilities and redefining what it means to thrive in the future of work. So, this is sort of the overview of my talk. And since I'm a professor, let me start with a brief history. The term AI was coined by John McCarthy in 1955, who is known as the father of artificial intelligence. Artificial intelligence, in its broadest sense, is intelligence exhibited by machines, particularly by computer systems. It is a field of research in computer science that develops and studies methods and software that enable machines to perceive their environment and use learning and intelligence to take actions that maximize their chances of achieving defined goals. AI was founded actually as an academic discipline in 1956, went through multiple cycles of optimism, followed by periods of disappointment and loss of funding, which are known as AI winter. Interest significantly increased when deep learning outperformed previous AI techniques in 2012. Deep learning has profoundly improved the performance of programs in many important subfields of AI, including computer vision, speech recognition, natural language processing, image classification, and so on. The reason that deep learning performs so well, in fact, is actually unknown to most of us till date. But in November of 2022, OpenAI introduced ChatGPT and the madness started. A generative AI combined with large language model called ChatGPT and its variants have achieved a new level of artificial intelligence. The smarter chatbots can perform research, support reasonable good writing, and generate realistic video, audio, and images. These emergence of AI was supported by GAN, a technology that I'll talk about in this talk. Two important facts that I want to remind ourselves. This sudden success of AI did not occur because of some new disruptive theoretical breakthrough. Deep neural networks and backpropagation, which are the backbone of this technology, had been described by many people as far back as the 1950s. But the increase and sudden success of AI is because of two factors. The first is the incredible increase in computing power, including the hundredfold increase in speed by switching to GPUs from CPUs, and the availability of vast amount of training data, especially the giant curated dataset used for benchmark testing such as ImageNet, as many of you may be aware of. So now that we are in the world of AI, there exist numerous tools covering a wide range of AI and tech applications, including writing assistance, transcription, image generation, project management, and coding support. As an example, for writing and language tool, there exists Grammarly, WordTune, Quillbot, Copy AI. For audio and transcription, there exists Otter AI. ChatGPT and DALI are generative AI tools where DALI is an AI system for generating images from textual description. That exists Canva or Midjourney for enabling design and creativity using AI tools. For productivity and organization, there exists Notion or Asana. For development tool, there exists GitHub Copilot or Rewatch AI. And there exist many other notable entries. So the collection here in the slide represent a broad spectrum of AI applications as everyday tools, from content creation and productivity enhancement to specialized tasks like image generation and assistance. This clearly illustrates the growing integration of AI technologies across various sectors of the tech industry and in general in the workplace. How these tools are helping in the workplace. Here are some details. The first detail is that they are providing an incredible opportunity in automation. AI powered automation is transforming various industries by handling routine tasks more efficiently, allowing human workers to focus on higher level activities. For example, manufacturing is using robotics, machine learning, and AI driven systems for automating assembly lines, quality control, and maintenance. The benefit comes as increased production efficiency, minimized downtime through predictive maintenance, and reduced labor cost. Intelligent automation is also helping with data entry and processing. Tools can process large volume of data, extract insights, and perform tasks like form filling, data validation, and reporting. And the benefit is that it reduces manual input errors, speeds up data processing, and ensures higher accuracy in results. Automation is helping customer services tools. Too, AI chatbots and virtual assistants can handle customer inquiries, answer to FAQs, and do basic problem solving. The benefit is it provides 24/7 customer services, reduces wait time, and allows human agents to address more complex issues, improving customer satisfaction. And last but not the least, AI automation incredibly helps routine office work. Tasks such as scheduling, email management, document review, and basic financial transaction are increasingly automated using AI tools. This frees up employees to focus on creative problem solving, strategy planning, and high impact work. AI tools are enabling advanced analytics too. Advanced analytics powered by AI allows for the rapid processing and analysis of vast amounts of data far beyond the capacity of traditional methods. This capability helps businesses and individuals uncover meaningful patterns, correlations, and insight that would otherwise be difficult or time consuming to detect. AI identifies trends in real time, offering predictive insights, automating data interpretation, and streamlining complex decision making processes. As a result, organizations can respond faster to market changes, optimize operations, and make data driven decisions with greater confidence and precision. Many of these tools that could be used are out there are used as AI companions that boost productivity by assisting with research, compiling information, drafting content, and enabling real time collaboration with teammates, streamlining various tasks for more efficient workflows. And finally, the tools offer key benefits even in remote work, including in task automation, streamlined information sharing, improved communication and collaboration, and enhanced management and skill development, fostering more efficient and productive remote work environment. One point to keep in mind is that historically speaking, AI helped humans to save time with features like intelligent search and recommendation. But Gen AI or generative AI that started in 2022 and onwards has been disruptive because it empowers humans to create. The computational framework that is the backbone of Gen AI is generative adversarial networks or GANs, as we call it in short. GANs are used to create images, videos, audio that seem like authentic recording of real situation. Just to give a little bit of context, a GAN uses two neural networks that have had simultaneous adversarial training. One neural network acts as a discriminator and other as a generator. The discriminator has been trained to distinguish between generated data and real data. The generator creates synthetic data and tries to imitate real data. And substantial training allows the generator to become better at generating ever more realistic data to trick the discriminator. As a result of this process, GANs can generate synthetic data that are difficult, if not impossible, to recognize whether it's artificial or real. And here goes some evidence of these benefits. This is one of the study that you see here in this slide. This study was conducted in 2023 and is considered to be one of the first major real-world application of Gen AI in the workplace. Researchers measured productivity of more than 5,000 customer support agents based primarily in Philippines at a Fortune 500 enterprise software firm over the course of a year. The tech support agents who use AI tools that created conversational scripts boosted their productivity, measured as issues resolved per hour by 14% on an average. But the improvement was even more pronounced for naive or novice workers who were able to get their work done 35% faster. In some cases, this study showed using AI actually trumped having real life work experience. Customer service agents with 2 months of experience who used AI support performed as well or better than agents with 6 months of experience or more working without AI. Meanwhile, the use of AI tools showed a minimal impact on experienced or highly skilled workers. In fact, as this study reports, the highly skilled workers oftentimes found AI to be a distraction. Quite an interesting study. And this benefit is not in the software form, it's going to be pervasive. In fact, according to the McKinsey Global Institute report, the estimation is that Gen AI has the potential to significantly impact the global banking sector by adding between 200 billion and 340 billion in annual value. This will represent 2.8% to 8.7%, 4.7% of the industry's total revenues. The primary driver of this value would be improvement in productivity achieved through the automation of routine tasks, enhanced data analysis capabilities, personalized customer interaction, and streamlined processes across various banking functions such as risk management, fraud detection, and customer service. GenAI could also enable banks to optimize decision making and innovations, ultimately transforming operations and contributing to overall revenue growth. Another interesting application, a team of researchers evaluated performance of large language model on the United States medical licensing exam or UCMLE, which consists of three steps. And it turns out that ChatGPT performed at or near the passing threshold for all three exams without any specialized training or reinforcement. Additionally, ChatGPT demonstrated a high level of concordance and insight in their explanation. So, this begs the following question. These results suggest that large language models may have the potential to assist with medical education and potentially clinical decision making. However, all these benefits that I have described so far is not coming without its challenges. AI brings a host of concerns, including job displacement, issues of bias and fairness, and other significant risks. The picture here, in case you can recognize, is the tentacle shagat used metaphorically when people talk about the potential danger or unknown consequences of advanced AI, as if the systems could grow beyond our control or comprehension. In the Lovecraftian sense, it's a reminder that we might be dealing with something whose full nature or impact is far beyond human understanding. As an insider, I don't fear as much, but I too feel anxious about the drawbacks of AI, especially its unintended consequences and ethical implications. So, I'm going to talk about some of the unintended consequences now. One of it is the job displacement. And before going to the details, I also want to give some historical perspective. It turns out that technological advancement always have played a significant role in shaping the job landscape throughout history. From the industrial revolution to the digital age, each era of technological process has led to displacement of certain job roles while creating new ones in the process. For example, industrial revolution marked the transition from agrarian economists to manufacturing based ones. While it led to unprecedented growth and creation of new industries, it also resulted in job displacement for agricultural workers who migrated to urban centers seeking employment in factories. And then, with the advent of computers and automation in the late 20th century, job roles in industries like manufacturing, banking, and retail underwent significant changes. Repetitive tasks were increasingly automated, leading to job displacement in some sectors, but also creating opportunities for workers in IT related fields. And finally, the emergence of the internet and information technology further transformed the job landscape. While certain traditional job roles were replaced by automation, new jobs in areas like web development, data analysis, and digital marketing were created. So, just like all of this, AI too will be replacing jobs, especially many low skill, repetitive jobs like data entry, telemarketing, customer service, and assembly line workers are likely to be replaced by AI and robots pretty soon. Even jobs that require technical skills are primed for AI automation. In the healthcare sector, specialized AI have been designed to analyze medical scans, detect diseases, and even diagnose conditions. So, all of these jobs seem to be replaceable to some extent by AI. And then, and probably quite importantly, the second unintended consequence of AI is the quality. AI is quite far from being perfect. And a recent article from the Harvard Business School examines the performance implications of AI on realistic, complex, and knowledge intensive tasks. The pre registered experiment involved 758 consultants, comprising about 7% of the individual contributor level consultants in the company. After establishing a performance baseline on similar tasks, subjects were randomly assigned to one of the three conditions. Subjects were given either no AI access or GPT-4 AI access or GPT-4 AI access with a prompt engineering overview. The outcome of this experiment created this jagged technological frontier, which you see on the slide, where this jagged technological frontier where some tasks are easily done by AI, while others, though seemingly similar in difficulty level, are outside the current capability of AI. In fact, while digging deeper on this data, it's seen that for each one of a set of 18 realistic consulting tasks within the frontier of AI capabilities, consultants using AI were significantly more productive. They completed 12.2% more tasks on average and completed tasks 25.1% more quickly and produced significantly higher quality results, more than 40% higher quality compared to a control group. Consultant across the skills distribution benefited significantly from having AI augmentation, with those below the average performance threshold increasing by 43% and those above increasing by 70% compared to their own scores. However, things to notice here that task, if it is outside the frontier of the AI line, consulting, doing the task using AI actually give a poorer performance. In fact, consultant using AI were 19% less likely to produce correct solutions compared to those without AI. So the bottom line is the effectiveness of AI is not ubiquitous, as its performance can vary significantly depending on the context, data quality, and specific applications. And finally, we cannot forget the ethical implications and challenges AI brings in. A famous story in this case is the use of this tool called Compass that was heavily, in fact, that is heavily being used in different United States for judicial decision making. The story goes as follows. In February 2013, Eric Loomis, an individual, was found driving a car that had been used in a shooting. He was arrested and pleaded guilty to eluding an officer. In determining his sentence, the judge looked at his criminal record as well as a score assigned by a tool called Compass. Compass is a tool that is developed by a company based out of New York, and it's a black box tool. Apparently, this tool uses 137 points on different aspects of the individual to come up with a score, which dictates the probability of reoffending by the individual. Using this tool, Compass classified Loomis as high risk of reoffending, and Loomis was sentenced to 6 years. He appealed the ruling on the ground that the judge, in considering the outcome of an algorithm whose inner working was secretive and could not be examined, violated due process. Fast forward to this story, Loomis did not get the justice he was looking for, but discrimination in AI software became well known, and algorithmic fairness received significant research attention in the community. So, pragmatically speaking, I would say we need to use AI, but use AI responsibility. Use AI responsibly. Using AI responsibly refers to the practice of designing, developing, and deploying AI in ways that are ethical, transparent, and aligned with societal values. So, at this point, I'll start laying out my vision towards achieving that. My first vision is not to replace human, but complement them with AI based automation. As AI will automate certain tasks, there will be an increased need for workers who can collaborate effectively with AI systems. Jobs that require creativity, emotional intelligence, and problem solving will likely to remain in demand and will benefit from human AI collaboration. There are two distinctive patterns of successful AI use by humans along a spectrum of human AI collaboration. The first one is centaur behavior, which is often used in scenarios where human intuition, judgment, and creativity are paired with the machine's computational power and efficiency. But in this model, the task that the human performs is clearly discriminated or clearly separated from the task that AI performs. I'll discuss a few projects that I'm currently doing that fit this model. The other model is known as Cyborg, that completely integrates task flow with the AI and continually interact with the cyborg metaphor and continually interact with each other. The cyborg metaphor actually goes beyond task completion. It represents a form of cognitive enhancement. By workers closely working with the AI, humans can leverage machine capabilities to extend their own cognitive limits. Whether it's drawing upon AI for rapid data analysis or using it to simulate possible outcomes, the human mind is effectively augmented by machine intelligence in the technology using the cyborg model. Cyborg model is highly popular in military application to enhance a soldier's senses such as vision or hearing, giving them an advantage in combat situations. And also, I plan to talk about one of my work that fits cyborg model. My second vision is to combine institutional knowledge with advanced AI capabilities for effective upskilling of workers. By integrating AI tools with existing expertise, developing targeted training programs, and fostering a culture of innovation, organization can enhance their capabilities and drive meaningful improvements. This approach ensures that AI not only complements but also amplifies the value of institutional knowledge, leading to more informed decisions, innovative solutions, and a competitive edge in the market. In nutshell, I'm a dire optimist and I imagine all the people and AI in the future of work where collaborative human and machine intelligence would lead to groundbreaking innovations everywhere, including in workplaces. But this vision is not an easy feat and comes with hefty research challenges. Here are some research challenges that I briefly described in this slide. The first being capturing human capabilities in AI design, which involves creating AI systems that effectively complement, enhance, and leverage human skills and attributes. Developing platform ecosystem and computational capabilities is a key research challenge. It is crucial for the development and deployment of AI systems. They ensure that the AI technologies can be effectively integrated, scaled, and utilized. Benchmarking and metrics are also crucial for evaluating AI systems as they provide objective measures of performance, effectiveness, and impact. And ethics, which is one of the most important aspects of modern AI technologies, which cannot be overlooked by any means. And clearly, achieving all of this cannot be done by an individual researcher or not even by a single research discipline. So this requires convergence of research disciplines. And in this slide, I outlined some of the initiatives that I have been doing to converge different research discipline and promote human and AI collaboration in the context of future of work. So really, I would like to say that the future of AI comes with the convergence of research and it needs to understand several research challenges to get the best out of human and AI. Now I'm going to change gear and I'm going to briefly summarize three ongoing projects in my lab that are designed to exploit human AI collaborative synergy. The first project, you call it as Human AI Agile Symbiosis. The goal is to design a framework to enable proactive, context dependent decision support with enhanced operational capability under uncertainty. The goal is to design a decision support tool for naval operator, and this project actually cleanly fits the Centaur model, human AI collaboration model that I described. Basically, we explore how to enhance the synergy of hybrid human machine intelligence to become more effective units, achievable via efficient multi objective optimization algorithm for agile mission planning that provide proactive, context dependent decision support with enhanced operational capability under uncertainty, time pressure, and resource constraints. The proposed decision support capabilities are applicable across a broad range of Navy applications impacted by uncertainty, such as ship, helicopter, UAV, submarine, aircraft carrier strike, routing, multi domain battle management, and unmanned system coordination. As part of this project, we develop an adaptive distributed context aware semi supervised team decision making framework for effective asset routing in a collaborative scenario. The developed solution emulates real world concept of operation or CONOP of a Navy asset navigator. There is substantial evidence in the literature that scenario thinking is important in human learning, and this very human look ahead capacity is the requirement for being able to make trade offs between short term and long term consequence. The developed framework is embedded in an existing tool called Templar, and that is now being used by the Navy vastly to improve the ability of ships to reroute through unpredictable weather. So I'm trying to play a recorded video of how it works and what it contains, and I hope you all can hear it.
This demonstration showcases our proposed solution, Team Planner, which is designed to assist the human operator guiding the navigation of N cooperative ships with respective starting points on a discrete grid to discover an initially unknown destination while optimizing for multiple objectives and avoiding collisions. Team Planner is currently being integrated inside Templar, which is a tool for multi-objective routing and asset planning in the naval domain. Templar was developed by the University of Connecticut and Naval Research Laboratory, Monterey. To better understand our problem, let us consider that 9 naval ships are in the Gulf of Mexico attempting to locate an asset of strategic importance. The asset's location is not known to the ships beforehand, and the ships must work together to discover the asset in the Gulf. They must avoid colliding with one another and minimize the total time taken to discover the asset and the total fuel consumption. This problem has been formulated as a discrete market decision problem. 3 reward functions, namely exploration reward, time reward, and fuel reward, are designed to optimize for the aforementioned factors while navigating the Gulf. Our MDP is solved by designing a reinforcement learning framework. Reinforcement learning is an area of machine learning that aims to maximize the cumulative reward obtained by an agent while exploring an environment. In our case, our agents are the different ships, while the environment could be any body of water, like the Gulf of Mexico. Our reinforcement learning framework consists of a teammate model that contains the belief distribution of each ship about the action of other ships at a given step. Reinforcement learning is suitable for our problem because we do not have any historical data on previous coordination among ships that would allow us to learn to develop a model of our own. Ships can choose to stay in their own position or move to neighboring nodes. They move in the direction where they can detect maximum nodes to maximize exploration, and the speed of ships is determined by the degree to which we're optimizing the fuel and time rewards. Here's a grid representing a small part of the Gulf of Mexico. 9 ships are in the Gulf, and all are trying to move cooperatively, discover an unknown destination or asset, described by the red circle. These ships must move cooperatively to the destination while avoiding collisions and minimize the total fuel consumed and the time taken to reach the asset, marked by the red circle. Thank you.
The second project that I want to discuss is called PASS, stands for Predictive Modeling for Ship Scheduling. This is to figure out um, how to plan maintenance, how to come up with a maintenance plan of US naval ships. Turns out that periodic maintenance and modernization of naval vessels, which are conducted in the shipyards, usually turn out to take a longer than expected time. And according to the US Government Accountability Office, the Navy's 4 shipyards completed 75% of maintenance periods late during the year of 2015 to 2019, causing late return of the vessels to the fleet. And naval vessels late return to the fleet results in a decrease in operational readiness due to the reduced number of operational days available for these vessels and impacts on other vessels assigned to support the same or a complementary mission. PASS was initiated as a multi-year initiative, and it's an ongoing initiative that started in September 2021 as a collaborative effort between NJIT, University of Connecticut, and NAFC Corona. And its overarching goal is to design tool for planning ship maintenance cycles. The problem is messy to say the least because the data is dynamic and uncertain and the process is overly complex. The used data is voluminous, come at different velocity, and consist of a different variety of types. Data required for year scheduling comes from multiple sources and organizations, and if you can see a few of them listed in this slide. Moreover, the collected data is of various types, such as unstructured data, time series, text, eventually also involve images, and data is sparse and contain different quality. And the data sources are sampled at different rates. Some of them sample daily, some weekly, some monthly, quarterly, or even on an ad hoc basis. The challenge here comes also from the process. There are multitude of interdependent factors that contributed to scheduling complexities. Some of this include inadequate planning for resources, quantity of overtime labor, direct year cost, and quality of work stoppages, experienced worker that contribute to the tardiness in availability. So the goal is to enable a predictive analytics for the year scheduling problem. And the challenge that it must go through a full data science pipeline that contains extensive upstream tasks for data conditioning assessment before being subject to advanced analytics or predictive modeling. The goal of this project is to enable this upstream data science capabilities that aids downstream AI, ML, or predictive analytics to qualitatively achieve software maintenance milestones. As part of this project, we have actually developed a software and we delivered an MVP the last month to US Navy that estimates the duration of maintenance of the ongoing ships, and it identifies human interpretable causes that are causing this delay, and these causes are meant to be actionable, and basically on top of that we also recommend mitigation strategy. So, as it turns out, this is a classical example of an AI project with human in the loop. And there is a clean demarcation of what AI does and what machine does. And in fact, keeping constantly human in the loop in this process because interpretability and explainability are some key requirements of these projects. And as it also turns out, that complex AI models are not suitable for these projects because things AI models that are fully opaque, like deep learning models, do not provide explanations. So one of the challenge that the research teams have gone through is to come up with a decision support system that is simple yet robust, and it can work well on controlled unclassified information, which basically we are dealing with. To summarize, a key innovation of this project is actually to design the entire data science pipeline. We have designed the entire data science pipeline of this project, starting from data integration to data cleaning to data exploration to feature engineering, all these classical steps that data science does, including evaluation, while keeping human in the loop on controlled unclassified information, and design a solution that is robust, interpretable, and easy to be adopted in the US naval domain for use. And the final project that I want to talk about is something that we organically identified while working on PASS. While working on PASS, it turns out that the data quality is the biggest challenge. And because many of the data sources that this naval database makes use are coming from unstructured data, and this unstructured data, the context of this unstructured data is wide ranging, and the forms are being completed in situ by the sailors. And the text being entered is typically poorly structured and inconsistent. As a result, the text bed data that is getting migrated to this database is not amenable to automated processing. And we felt that when we are dealing with this unstructured data in the form of structured content in modeling paths, the results were poor. So the traditional approach was to utilize such data uh, and perform extensive manual curation um, by different people than those who actually created this data. But this new project we call curation while creation comes up with this moonshot goal that how about we enable curation, uh, curation and creation at the same time. In fact, we try to create curated data, and the hope is this manual creation process that is usually expensive, imprecise, and time consuming, all of these be avoided if curation and the creation, both of these steps could be blend together with each other. So the goal of this project is to leverage Gen AI, and this project started after 2022 when Gen AI came into picture. So the vision was to leverage Gen AI technology to improve the quality of unstructured text that pervasively exists across many key naval data sources. The overarching goal would be to assist the end users with suggested text or drop down as recommendations, and that will minimize the data entry effort while giving rise to high quality unstructured text. The hope is that the desired solution will generate a general purpose curation while creation text engine that facilitates complementing a variety of text based forms. And we will be able to come up with a mechanism for incorporating technical terminology that are appropriate for specific domain usage. For example, those of you who are aware of it, US naval domain is full of jargon. And just slapping a general purpose Gen AI tool is not sufficient. So one of the technical challenges that we are dealing with that is how to leverage existing Gen AI model by training them to use specific Navy specific jargons. As part of this project, we come up with this modular framework. We call it Rubicon for building curation system for guiding text-based reporting at the time of entry. This curation system collaborates with the human report writers in real time to ensure high quality reporting and offer customized guidance for the report domain at hand. This collaboration is facilitated by an interactive inline suggestion interface, which reduces the user's burden for detailed report writing. The use of large language models or LLMs and report quality rubrics, which we come up with, is designed to work across a wide range of report domains, and its automated initialization curriculum minimizes the work and expertise required for standing up new curation system. Collectively, the goal is this framework will support Navy goals by enabling curation during creation for generating analysis ready data and improving data driven decision making. So that's sort of the three leading projects, three a project that fits the human AI collaboration model. And in case I haven't mentioned it yet, the last project that I described that actually fits the cyborg human AI collaboration model perfectly, because the hope is to augment human capability while human is writing so that the human can write more powerful and clean text. But I must say that I am not the only AI researcher at NJIT. In fact, I am just one of many of them. We have outstanding faculties, enthusiastic student body, and great resource to conduct AI research. And indeed, this is an exciting time to be at NJIT if you are interested in AI. Research on AI at NJIT is constantly growing. In 2023 alone, NJIT's research related to AI total nearly $60 million. And we just have devoted over $10 million for push in AI. NJIT offers a variety of degree program and certification at undergraduate, master's, and PhD level with concentration on AI. I encourage all of you to visit our campus, look at our website, and connect. And we will be happy to share more details of our AI initiatives and programs that are ongoing or upcoming. So, in conclusion, I want to say that we are in the midst of AI spring, and its progression is inevitable. There is no turning back from the transformative impact it will have in our world. So we will have to take AI and go figure. And here is my plan. I want to suggest for workplaces, we'll have to mentor the future workforce, preparing them for the evolving AI driven landscape. We will have to seek out organic opportunities to invest in AI driven solutions that benefit businesses and society. For workers, we have to focus on developing a strong foundation in engineering and algorithmic skills to stay competitive in AI driven economy. And for researchers like us, we have to prioritize making AI responsible, ensuring it promotes fairness and inclusivity while supporting workers and not replacing them. So let's be proactive and adapt so that the benefit of AI are broadly shared in the future of work while minimizing its risk. A little bit of advertising while I end. This is about my group at NJIT. I direct the Big Data Analytics Lab. We conduct interdisciplinary research focusing on large scale data analytics problems that involve human AI collaboration. And I would be a remiss if I don't give a shout out to my team and my sponsor at this point. None of this would have been possible without incredible hard work of each and every member of my team and the generous support from my sponsor. Thank you.